write the program and we will demonstrate the program. Okay. So first, let's assume we have we need to generate a delay of 5 milliseconds. Okay. Okay. So the program will be program to generate a delay of 5 milliseconds with 50% duty cycle. Okay. 50% duty cycle. Okay. Now we'll see how we can write the program. Now see here, for timers we have seen that the oscillator frequency, whatever we are taking, that oscillator frequency is the inbuilt oscillator frequency divided by 12. Okay. Now this oscillator frequency we will consider as 11.0592. Okay, megahertz. That will be the internal frequency. Now, if you want a delay of 5 milliseconds with 50% duty cycle, so here we can write the program in two ways. Either generate a delay of 2.5 milliseconds for on period and 2.5 milliseconds for off period, or just do one thing. Generate a delay of 5 milliseconds for on period and generate a delay of 5 milliseconds for off period. So here what we will do, we will generate a delay of 2.5 milliseconds for on period and 2.5 milliseconds for off period. So let's assume here whatever the frequency delay given is 5 milliseconds. So that will get divided by 2. So actual delay will be 2.5 milliseconds. Now why we are dividing it by 2? Because we have a duty cycle of 50%. Okay. And what is the meaning of duty cycle? It is the ratio of off time to the on time. Okay. So that will be the duty cycle. So here the duty cycle is 50%. What does it mean? For on period that will be half time and off period will be a half time. So the actual delay will be of 2.5 milliseconds for any one level, either high level or low level. Okay. Now here what we will do, we will write a program for that. So first we need to generate a T-mod. Okay. Now if we see the T-mod structure or SFR, then the higher 4 bits are for timer 1 and lower 4 bits are for timer 0. Okay. One more thing which we have forgotten to write here, that is here we need to use timer 0 in mode 1. Now why we are taking mode 1? Because here we can use the 16 bits of two counting registers TH and TL. Okay. So we are taking mode 1. If we want to change it to mode 0 or mode 2, that also we can do accordingly. Okay. So here the mode T-mod register will have upper 4 bits for time T-mod timer 1. So that will be 0000 and lower 4 bits for timer 0, in which the D3 bit is gate that we need to keep it as 0. Then the next bit is C/T bar. So as we are using it as a timer, that bit also 0. Okay. And mode which we are using is mode 1. So the bits will be 0, 1. Okay. So it is equal to 0, 1H, which we need to load into the T-mod register. Okay. The second is we need to set the count for TH0 and TL0. Okay. So for that purpose, here what we need to do, we need to divide the oscillator frequency by 12. That will be the first case. And after that, whatever the time which we are getting, we need to divide the actual time delay by that time period. Okay. So oscillator frequency is 11.0592 megahertz. That will get divided by 12. So the answer will be, we'll take here 11.0592 divided by 12. So it is 0.9216. So it is 0.9216. It is in terms of frequency, megahertz. Now this frequency we will convert into the time. So time, capital time T is equal to 1 by 12. That is equal to 0.9216 divided by no, here it is the frequency, right? So it will be 1 divided by 0.9216 megahertz, which is equal to 1 divided by 0.9216. It is 1.08085. So we will take it as 1.086 microseconds. Why microsecond? Because here it is having 0.9216 megahertz, that is into 10th power 6. So when it goes to the numerator, it will be 1.086 into 10th power minus 6. So it will be 1.086 microsecond. That will be the time delay generated by one clock pulse. Okay. So here, that clock pulse, how many clock pulses does we require to generate 2.5 millisecond delay, that we need to calculate. So actual time count or actual delay is equal to 2.5 millisecond divided by 1.086 microsecond. Okay. So the actual delay will be it will be 2.5 divided by 1.086. So it is 2.30302. Okay, so 2.302 into 10th power microsecond. So it will be 10th power 3. So it is equal to 2302. That will be the time count, okay, which is required for actual delay. Okay. Now, from this time count, we need to subtract this count from 65536. Why it is 65536? Because 00002 FFF maximum count is 65535. So here what we are doing, 65535 minus count, that is 2302 plus 1. So that plus 1 we have already added here. So it is 65536 minus 2302. Okay. And the result will be 65536 minus 2302. It is 63234. 63234. That will be the actual count which we need to load into the TH and TL register. Okay. So here we will convert this value into the hex. Okay. So 63234, when we convert it into hex, the result is F702. So in terms of hex, it will be F702. F702H. Now here, this F702 we need to load into TX0 and TL0. So for TH0, the higher 8 bits are F7, and for TL0, here the lower 8 bits are 02. That we need to load into the TH and TL bits. Okay. Now here we will write the program. First is org 0000H. Then move tmod comma hash 01H. Why hash 01H? Because here we have taken the value into the tmod as 01. Then move, and here it will be org. So we have transferred the contents into the tmod R01. Now we need to load th and tl register. So th0, that is move th0 comma hash 0f7h, and move tl0 comma hash 02h. Now these contents were transferred into the th0 and tl0 count. After that, to check the delay, here what we are doing, we will complement the port pin. Okay. Let's say CPL port 1.0, complement port pin. And after that, what we do, we start the timer with instruction set B TR0. Okay. Now here this TR0 bit is available into the TCON register. Okay. And after starting the timer, we will wait unless and until the TF0 flag is set. Okay. So here what we will do, we will write unless and until TF0 bit is set. Now here, when the bit is set, then what we need to do? We need to stop or clear TR0 and clear TF0. Okay. And after that, we need to give the unconditional jump as jump to the up. Okay. And this up will again we need to provide to this location for loading the time count for TH0 and TL0. Okay. Then last will be S jump dollar and then enter. So everyone got it? What we have done here? First, we have set the timer 0 in mode 1 by transferring the content 01 into the tmod register. Then in TH0 and TL0, these are the count registers which are available in the timers. So for timer 0, we have TH0 and TL0, where we have loaded that registers with F7 data and 02. And this data is available, or we have calculated using this process. Okay, so first oscillator frequency that we have divided by 12. Then that from that frequency we have calculated the time for one T state, and according to how many T states are required, that will get calculated by 2.5 millisecond, or the actual delay required. We have divided that delay with that actual delay for one T state. Okay, so according to that, we have calculated the TH0 and TL0. And to check this status, we have complemented port pin, port 1.0. Okay. And after that, we have started the timer and we have checked the status of TF0 bit. So unless and until this TF0 bit is set, we need to wait for that. That means this delay will get generated here. And when this TF0 bit will get set, when the count rollovers from FFFF to 00. Okay. So at that time, here this TF0 will get set. And once it is set, we are just clearing the TR0 bit. That means we are stopping the timer and we are clearing this TF0 bit, so that after again restarting the timer, the TF0 bit should be clear for that purpose. Okay. So this is the complete program. Okay. Now we will write the same program, or we will take this program into the key. So I am writing this program. I am checking here. Syntax error. Backgen bit TF0. Okay, so here there are no errors. We will run the program here. Now here to check the conditions here, what we'll do, we will open port 1. We'll check the status of port 1. Then we will open timer 0 and also we will open logic analyzer. And we will set up this logic analyzer. So here it is port 1.0. Close. And we will just see here tmod 01. So here the value in tmod is 01. That means here it is 16-bit timer counter, and the count in tmod is 01. Then the next is TH00F7. See here for TH0 the value is 0F7. Then TL002. Here the value is 02. After that, we're complementing port pin. See here, this pin is 0. Previously it was 1. And then we are waiting for 2.5 milliseconds. Right? And after that, here again it will get returned back. Okay. So I am running the program here. See here, we are getting the delay. Okay. Here the timer is running. Okay. And I am stopping it. See here, for every clock cycle, it is for 50% duty cycle. You can calculate here port 1.0. Here see the time 10.60507 seconds. Okay. And here if we take this value 10.60622. Okay. Here it is 10.507 to 622. Okay, so that will be the delay for lower time. That will be again for higher time, and lower time and higher time, so on. So we are getting here 50% duty cycle. Okay. Similarly, if we want to change the delay accordingly, I think that program we have taken, or I have showed you the demonstration, na? अरे हात का जागे सगळे. Okay, that means for 2 milliseconds and 5 milliseconds. I think I have shown you the demonstration. Okay, so this is all about. Sorry, that is all about the timers. Okay, now here this program we have done in assembly language. Okay, if the same program, if we want to perform in embedded C, we need to take some. So for embedded C here, what we need to do to keep into the infinite loop. Here we need to use the function while, and in while loop we will directly give the value for tmod, TH0 and TL0, and then directly we will start the timer. Okay, so you can try that program yourself. If you are having any queries, we will solve the same program into the next lecture. Okay, so here for assembly language programming, we need to set the tmod, TH0 and TL0, and then we need to write the program. Now here the same this program we have taken for timer 0 in mode 1. Okay. Now if I want to use mode 2, okay, that is timer 0 mode 2, or we will take timer 1 here now, okay, because last 2 experiments are taken with timer 0. So here we will use timer 1 in mode 2. Now mode 2 is auto reload mode. Now what does it mean? Whatever the value which is getting overflown from or rollover takes place into the TL, then automatically the new count or the previous count that will get loaded from TH into the TL. Now, if we want to write the same program for mode 2, keep in mind when we are taking mode 2, here the maximum count which we can load into the register is 00 to FF. Okay. That means here the maximum delay will be 255 multiplied by 1.08 something. What was the 1.086? Okay, so 1.086 microseconds. So it is equal to, here we calculate 255 multiplied by 1.086, 276.9. That means we take here as 277. That much of microseconds, right? Microseconds. That much of delay which we can use or we can give using mode 2. Okay, everybody understood it? Here what I have done, if we want to use mode 2, then we have the maximum count, that is 255, and for one pulse we have the delay of 1.086. That means 277 microseconds will be the maximum delay which we can provide in mode 2. Okay. Now, according to this delay, if we want to calculate the frequency of that time of the wave, okay, see here we have generated the square wave. Okay. Now, what will be the frequency here for this square wave? Here it is 5 milliseconds. Okay, for one cycle here it takes 5 milliseconds. So what will be the actual frequency for that 5 millisecond delay cycle here? What will be the frequency? F is equal to 1 divided by 5 milliseconds, which is equal to 20 kilohertz. I think it will be 1 divided by 5, 0.2. It will be 0.2 kilohertz. That will be the frequency for that particular wave. Okay. Similarly, here the maximum cycle or the frequency for that wave, square wave, we can calculate by 1 divided by 277. Okay. So the frequency will be 1 divided by 277 equal to 0.00361. So here we take 0.0036. It is in microseconds. Okay, so it will be into 10th power minus 6. Okay. So it is 0.0036 megahertz, or we can write here it as 3.6 kilohertz. That will be the maximum frequency which we can use or which we can generate using the delay. Okay. So here in this program, here what we'll do, we will generate a frequency of 3 kilohertz. Generate frequency of 3 kilohertz using timer 1 mode 1, or sorry, mode 2, that is auto reload mode. Okay. So here what we'll do, oscillator frequency divided by 12, it will be the same as it is. Okay. So time period, here we will directly take the frequency 0.9216 megahertz. Okay. So here the actual frequency is 3 kilohertz. So 3 kilohertz divided by 0.1296. Am I right? 0.9216. Okay. So it will be 0.9216 megahertz. Okay. So here it will be 3 divided by 0.9216, 3.255. It is 3.255 multiplied by 10th power is kilohertz, so 3 megahertz minus 6 into 10th power 9. Okay, that will be the frequency. So according to that, the time will be equal to 1 divided by f. So here we will divide it by 3.255, 0.3072, 0.3072 multiplied by 10th power minus 9. I think the time count t will be equal to 3072 0000. I think it's too much. So here we will take the frequency in terms of hertz. Then it will be megahertz will be in microseconds. 10 to the power minus 9. 10 to the power minus 9. So t equal to 1 by 0.3092 into 10 to the power. Here I will keep minus 6. Minus. So time period t will be 3072. 3072. Still it is too much. 3 kilohertz. If we generate 1 hertz, then megahertz. So it will be 1 into 10 to the power minus 6. One zero zero 655 0.1. So 0.1, then 0.1 divided by 0.9216, 0.1085. So it will be 0.1. It will be 0.1. 10000. Okay, so if we generate 0.1 hertz frequency also, then the value or the time count comes in terms of 5 digits. Okay, so we cannot convert that into FF. Okay, so here maximum count in FF will be 255. So here we need to take 16 bits, that is 65536. So here the mode should be taken, required will be timer 1. So it will be 65536. Huh?
So 4K frequency घेऊन येते 230 काउंट येतोय.
काय झालं?
4K हर्ट्ज फ्रिक्वेन्सी घेतली की 230 काउंट येतोय.
4 किलोहर्ट्ज फ्रिक्वेन्सी घेतली की 250 येतो.
230.
Okay, okay. Just I need to check 4 kilohertz. 4 kilohertz. Okay. So 4 kilohertz घेतल्यानंतर what will happen here? 4 kilohertz divided by 0.9216 megahertz. So value will be 4 divided by 0.9216. It is 4.34. Right, 4.34 multiplied by, it is 10 power 3 and it is 10 power minus 6. So it is 10 power 9, na?
-3.
Am I right? -3, how it is? It is in kilohertz, na? So 4 into 10th power 3. And here it is megahertz. 10th power minus 6.
पण
Sorry.
divide आहे ना sir ते.
That's, I have done the mistake here. It is 10th power 6. So when it goes up, it will be 10th power minus. It will be -3, right? Okay. So here the time will be t equal to 1 divided by f. So it will be 1 divided by 4.34. It is 0.230. So it is 0.230 into 10th power 3 into 10th power 3. Okay. So the time count t will be 230, right? So according to that, if you want to in mode 2, the count will be 256 minus 230, which is equal to 26. Now why it is 256? Because 255 minus count plus 1. Okay, so it will be, the count will be 26. And when we convert that value into the hex value, then 26, when it is converted into the hex, sorry, here it will be 26 converted into hex 1A. So the count will be TL. Okay. So here in his program, if you are taking mode 1, timer 1 in mode 2, that is auto reload, then simply just like the previous program, here we need to set the TMOD register and TL0 now here. So ORG 00008, then move TMOD comma hash. Now what will be the value for TMOD? Upper 4 bits for TMOD register, upper 4 bits are for timer 1 and lower 4 bits for timer 0. So for lower 4 bits will be 0000 and upper 4 bits will be first bit, gate bit will be 0, C oblique T bar will be 0. Now it is mode 2, so the count will be 10. So the value will be 2 and 0. So in TMOD we need to put the value 20H. Okay. Then move TL0 comma hash. What is the value here? 1A. So it is 1AH. Now when we are loading the value in TL0, the same value will be available in TL0. So it is not necessary to load TL0 again. So only we need to move the value into the TL0. Okay. After that, simply just like the previous program, we complement port 1.0. Okay. Then set B. Now see here, one more thing here. We need to use TL1 here because we are using timer 1. Okay. Here also set B. Now we need to start timer 1. So it will be set B TR1 and we will check the status of which bit? TF1 bit. Okay, so here we need to check TF1 bit because for timer 1 here we have TF1 bit. After that, here simply we will TF1. Now here, where we need to give the up? By default, when the TL1 gets overflown or rollover takes place, automatically the value will get again reloaded into the TL1 from TH1. So here only we will give the loop to the event, not to the count. Okay. And then let's jump dollar and add. Okay, so got it. So here what we have done for tmod racer, as we are using timer 1, here the value will get changed into then for count we have taken the count into the TL1 register. Okay, that is 1A, and we have just complemented code 1.0, that is for event generation. And after that, only we have started the timer and we check the status for TF1 bit. Okay, so the same program we will take into the key. Next error, CMB TF1 comma. Okay, and we'll debug it. Now check here, the tmod count is 20, then the value for timer 1. See here, tmod is 20, that means here it is 8-bit auto reload mode. Okay. Value in TL1 will be 1A. And we will check the status for logic analyzer also here. See here, we have got the result. Okay, so here automatically the value will get loaded from TL1 into TH1 into TL1. Okay, so by default when we are giving the value in TL1, the same value is available into the TH1 and that will get auto reloaded into the TL1. Okay, everyone got it? लक्षात आलं का सर्वांच्या? I think that's enough for today. Tomorrow we will perform the practicals for embedded C. Okay, so same